Alright, continuing with the quartiles, we have what's called the interquartile range, which is called the IQR. The IQR is Q3 minus Q1. It represents the middle 50% of the data, which means it kind of cuts off the outliers, it ignores the outliers. So it gives us an approximation for the spread the middle percent of the data, neglecting potential outliers. So when our data is symmetric, we said we use the mean and we can use the standard deviation because everything's kind of symmetrically separated. When the data is skewed left or right, we want to use the median, and instead of using the standard deviation for spread, we use the interquartile range. Now for our class, we kind of stick to symmetrical data. But if our data is skewed, we want to use the IQR instead of the standard deviation to report the spread. For this course, we're going to use the IQR to help us determine where the outliers fall. So outliers, extreme observations, are calculated in a very particular way. So depending on the data set, there might or might not be outliers. And there is a specific formula to calculate the outliers. It's not just eyeball, oh, that kind of looks like one, or maybe that's not one. There's a specific formula. So how to check for outliers by using the quartiles. You determine the first and third quartiles of the data, that's what we call Q1 and Q3. We compute the interquartile range, which we call the IQR, and then we set up something called the fences. So fences serve as cutoff points for determining the outliers. The lower fence is Q1 minus 1.5 times the IQR, and the upper fence is Q3 plus 1.5 times the IQR. So if a data value is less than the lower fence or greater than the upper fence, we call it an outlier. And we're going to draw a visual for this as well, so hopefully this will all kind of start to sink in. This computation is on your formula booklet. Just want to point that out to you. Right below your z-scores, you have your IQR, and you have your lower and upper fence. So you don't have to memorize those. They're all right there. And then we'll get into the 5-number summary here in just a minute. All right, so here's a fresh set of data. What I'd like you to do is put those numbers all into L1 using your graphing calculator. So stat, edit. If there's anything in there, go up, hit clear, and then enter. We're going to enter all the data values and push enter in between in any order. Double check as you go along that you've entered the numbers correctly. Just entering the data in any order. I believe these are monthly salaries for different employees at a company. So the monthly salaries. Glancing at the data table, you might notice kind of a low value, or you might notice a high value. So those might be outliers, but we're going to run these calculations to make sure of whether or not they're outliers. So we've put the data in L1. Now we're going to go to Stat, Calc, 1var Stats. Remember on the older calculator, just hit enter. We have X bar, we have those other numbers we're not going to worry about. We have standard deviation. We're going to go down, and you should see the minimum. Sorry about the glare. Make it a little darker. You should see the minimum, Q1, median, Q3, and the maximum. And we're going to use Q1 and Q3 to help us find the interquartile range. So Q1 was 735. Q3 is 4668. We're going to calculate the IQR by doing 4668 minus 735. 668 minus 735. Oops. subtract them, don't add them, subtract them. So we're going to subtract Q3 minus Q1, and that gives us 3933. That is our IQR. We're going to use those formulas to get our fences. So we're going to do Q1 minus 1.5 times the IQR. So Q1 was 735 minus 1.5 times the IQR 3933. You can enter all that in the calculator at the same time. 735 minus 1.5 times 3933. It gives us a negative value, and that's okay. That's just saying our lower fence is negative. That's no big deal. So we get negative 5164.5. And again, we're going to put all of this on a number line soon, so it should help it make even more sense. Now we're going to do the same thing with Q3. So we're going to do Q3 plus 1.5 times the IQR. So Q3 was 4668 plus 1.5 times that same number. We get 10,567.5. I got a little crammed down there. So we have our lower fence and we have our upper fence. And the question is, are there any values that are considered outliers? Because our lower fence is negative and none of our values are negative, there's no lower outliers, nothing below that negative number. If we look at 10,567.5, that 21,000 is an outlier. This 10,000 is almost an outlier, but not quite. So the 21,147 is what we call an upper outlier. So I know that's a little confusing right now. It'll make more sense when we put it on a graph. But you have the lower bound, and if anything's smaller than the lower bound, it's an outlier. And you have the upper bound or upper fence. Anything above the upper fence is an outlier. Alright, so let's get this onto a visual graph to kind of help us out. So section 3.5 goes right along with 3.4. It's called the 5-number summary and box plots, or box and whisker plots. So the 5-number summary is the first thing we're going to talk about. We've seen all of these numbers before. We're just going to make it an official list. So the 5-number summary is the lowest data value, and we call that the minimum. It is the first quartile limit, which we call Q1. It's the median, or the second quartile limit, which is abbreviated MED. Then it's the third quartile limit, which we call Q3. So Q1, median, Q3, and then the highest data value, or the largest data value, which we call the maximum. So abbreviated, it's minimum, Q1, median, Q3, and the maximum, in that order. So when you run one of our stats, I don't know if I have my list in this calculator or not. Alright, when you run one of our stats, the last 5 numbers you get, min, Q1, med for median, Q3, and max, that is your 5-number summary. So let's look at a fresh data set. Let's clear that out. Go ahead and put all the values from table 17 into L1. .47. Careful when you have decimals, just always visually make sure that you put the decimal in the correct spot. And again, these can go in any order. It doesn't matter as long as the numbers are correct and you have the right amount, the right number in your list. Your sample size has to be the same. Almost done here. Alright, so there's 21 in our list, which means our cursor's on 22, which means you put all your values in. Then we're going to go to stat, calc, 1var, oops, not that. Stat, calc, 1var stats. We need the last 5 numbers. So our minimum is 19.95. Our Q1 is 26.055. Our median is 30.95. Our Q3 is 37.24. And our maximum is 54.63. So you need your 5-number summary. And from that, we're going to draw what's called a box plot, or a box and whisker plot. So the first thing we need to do is determine the fences, the lower fence and the upper fence, like we were just practicing. So let's get our IQR for this data. 26.055. And you can subtract them in either order. If you get a negative number, just know that it should be positive. So I subtracted them out of order, but it's okay. 11.185 is my IQR. Now we're going to get our lower and our upper fence. Lower is going to be Q1 minus 1.5 times the IQR. Again, don't worry about the negative if you subtract them out of order. Just use the value itself. I'm just going to double check my numbers here. I'm getting different results than I have before. I'm just going to double check my numbers. Sometimes the textbook updates the data sets without me knowing. Let's see. Okay, good. You should be getting the same numbers I am. I'm just making sure. Stat, calc, 1var stats. Just double checking here. Yep, okay, we're good. So we got our IQR. Okay. So our lower fence was 26.055 minus 1.5 times the IQR. I got 9.2775. And then one more time for the upper. It's going to be the Q3. Sorry, you can't see what I'm typing in here. The Q3 minus, nope, not minus, plus 1.5 times the IQR. So again, it's Q3 plus 1.5 times the IQR for the upper fence, Q1 minus 1.5 times the IQR for the lower fence, and both of those formulas are on your formula sheet. So 54.0175 is my upper. It's kind of tedious to get all these numbers, but it's really helpful for drawing our box plot. Alright, so we have lower fence, we have upper fence, and we have our 5-number summary. So let's draw a number line long enough to include the maximum and the minimum values. So I kind of gave you a template at the bottom here. The minimum value is 19.95. I'm just going to go ahead and start at 0. And our maximum is the 54.63. So I'm going to count by 5s. The scale will already be done for you. This is just if you have to scale it yourself. 35, 40. I'm just going to count by 5s. Give me a good range here. Good enough. So I just started at 0 and counted by 5s. Insert vertical lines at Q1, the median, and Q3. And close these vertical lines in a box. So you kind of have to eyeball where your numbers are. 26.055 is somewhere about here. Median is right about 31, a little bit bigger than 30, and Q3 is at 37.24, right about there. We're going to put those guys in a box. And not to be perfect, just a box. Again, this is Q1, median, and Q3. And then it says label the lower and upper fences. So our lower fence was 9.2775. I like to label my fences with a long dotted line. Your textbook just kind of puts one little mark. It's the same idea. I like to make a long line. Upper fence is about 54. So fence there. So you have your box, you have your fences. Step 4 is a little confusing. It says draw a line from Q1 to the smallest data value that's larger than the lower fence. When it says larger than, I think inside the lower fence. So inside the fence would be here, outside the fence would be here. So inside the fence is in this region for the whisker, and then up here is for the upper whisker. So the smallest data value that's larger than the lower fence. So our lower fence is 9.2775. Fortunately for us, our smallest number is 19.95, so that's where my whisker is going to end. It's going to go as far down as it can to the lowest data value, and because it doesn't cross the fence, we draw a whisker. So think of this kind of like an electric fence, right? Nothing can cross it. Same thing on the upper side. Draw a line from Q3 to the largest data value that is smaller than the upper fence. And again, instead of smaller than, just think inside the fence. So my biggest number is 54.63. My upper fence is 54.0 something. So I can't put the whisker up to here. So I need to look in my data for the next smallest value, which looks like the 49.17. So it's the next biggest or smallest. So I can't go all the way to the maximum, but I can go to the next value. So 49.17 is the highest I can draw my whisker. My whisker cannot cross my fence. If you think of it like an electric fence, whiskers cannot cross the fence. So sometimes this is called a box and whisker plot because we draw these little lines that we call whiskers. So again, whiskers cannot cross the fences. So draw your fences first, and then you draw your whiskers as low as you can go, given your raw data. You always have to look back at your data. Look at your data. Find the smallest number you can that does not go past the lower fence. Then find the biggest number you can from the raw data that does not go past the upper fence. Anything that goes past the fences, so any data values less than the lower, greater than the upper, are called outliers, and you mark them with a star. So this 54.63 is right outside that fence, so we mark it with a star. Or a dot or a circle, whatever kind of shape you want to. This book talks about stars. So any values above the upper fence get stars, and there could be more than one. Any values below the lower fence get stars, and there could be none or there could be several. Alright, so that's box and whisker plot. We can do this again. You can work this one on your own. I'm not going to take time in the video because it might cut me off. But you can put all these guys in L1, get your 5-number summary, and sketch out your box plot for practice. This is one of the problems in the book. You can do the same thing in the calculator. So I'm actually going to do this smart car example in the calculator with you. So if we put all this data in L1, again in any order, let's take a second and do that. Wish I could somehow preload these in the calculator, but I can't. So go ahead and do this with me. Put all the guys in L1, all your data values in any order. Almost there. Don't go too fast. You want to make sure they're all entered correctly. If there's one that shows up more than once, put it in more than once. This is called the raw data. and you want to enter it exactly as it shows. So enter that raw data exactly how it shows. So put all of those in L1. I'm going to go to stat. Well, we don't even need to do that. You can go to stat calc 1-bar stats and get the 5-number summary. So I'm going to let you do that on your own. You can fill in the 5-number summary. I'm going to show you how to get a box plot from the calculator. So you're going to push second y equals, and again, this is from the book. The book kind of tells you how to do it. Second y equals. So you're going to push second. When you push second on these calculators, it puts a little up arrow. You can do the same thing on an older calculator. Second y equals. Y equals is that top left button. It pulls up what are called stat plots, and I'm using the old and the new. It's the same thing. You're going to hit enter. You're going to hit enter again to turn the plot on. Make sure on is blinking in black. On the newer calculators, you'll see all 6 types in a row. On the older calculators, they're broken into 2 lines. Either way, you're going to put the down arrow first to get to type, and then you're going to go over until you see the box plot with the little outliers, and you're going to push enter. So here, you're going to go over, over, over. Don't go down, go over until you see the box plot with the blinking, or with the dots, with the outliers. And it should be blinking in black, so hit enter to make sure it blinks in black. Your X list is L1. Your frequency, FREQ, is 1. The mark, you want to stick with either the box or the plus. Don't go so small. The newer calculators go really small. Don't go so small. I would just keep it at the box. I have a color screen calculator. You don't need to worry about color. Then you're going to hit zoom. Zoom is at the top center of your calculator. You're going to push zoom. So it tells you here zoom. And you're going to go down to option 9. Option 9 says zoom stat. So stat stands for statistics. So you're always going to choose zoom in the middle at the top, option 9. And you should get yourself a nice pretty box plot. This is from a different set of data, so it doesn't show the outlier. This is from the car data, so there's your outlier. This is from a different set of data, so don't look at that one. That's your car data right here. So when you can hit trace, trace is right next to zoom. If you hit trace, you'll see the minimum. I know it's hard to see, the font's small. You'll see the blinker on the minimum, and you go over Q1, over to the median, over to Q3. It'll tell you where to stop your whisker, and it will tell you the value of the outlier by going over, over, over. Same thing on the old calculators. If you hit trace, you push over, over, over to see those values, and it tells you at the bottom what they are. Again, this is an old data set, but there's your box plot for your smart car data. Alright, so the video might cut me off to finish this up. Hopefully it will not. The symmetry of the box in a box plot with the median will help us determine if the data are bell-shaped or skewed. The length of the whiskers also helps us describe the shape. So the outliers will skew the data. The position of the outlier determines the direction of the skew. So if you have an upper outlier, you're going to skew right. So if the majority of the data is here and it skews right, you see how your right whisker is stretched? That's skewed right. Bell-shaped data have nice symmetrical bell curves. Sorry, that was a bad curve. But it's nice and symmetrical. And skewed left, if you have a lower outlier, it skews left, and it's going to pull down that lower tail. So box plots and bell curves are related. All right, that is it for Chapter 3. Again, a big chapter. Make sure to study and practice Chapter 3 a lot to have a full understanding for this exam and future exams as well.